we worked on taking a product called MathTrax that was developed originally at NASA. It's an open source product, and it's used for educating students with visual impairments about math. Since they can't see the graphs that a formula makes, we looked at creating other ways to be able to convey that information. One is by automatically leveraging the descriptions that MathTrax generates, and being able to put those in a browser-based environment where you could then listen to it using a traditional screen reader, or potentially even integrating with text-to-speech APIs for self-voicing behavior. And then we also looked at taking some of the graphing technology, which in the past had generated images that weren't easy to print on what they call a tactile printer. We now are generating SVGs that can be printed on the tactile printer, and we've started the work necessary to figure out how to actually make it print on a very inexpensive 3D printer, such as one of the MakerBot printers. And then we wanted to make this technology easily embeddable in ebooks, particularly EPUB 3 books, and for that we wanted to make sure that it would work even when the user didn't have an internet connection. So we experimented with using the web audio API in HTML5 to sonify the graphs so that people could hear an auditory description of, not description, but an auditory representation of the data.
Okay, so I was working on making the math description engine, which NASA had written in 2003. They'd written it in Java, so I was planning on making it more accessible through the web. So this is what used to happen when you ran the MDE. You get this sort of Java window, which would have the graph in it, which is great, but Java isn't really the best sort of client tool for the end consumer to use. So I was able to take all their work and then use that to create an actual SVG, which you can see it here, and then to prove it, I don't know how well this will come out, but if you look at the page source, you will see that it is actually an SVG file. You have to take my word for it, so I'm not sure how well the text appears. But so we're able to get SVG from the math description engine, and then we're also able to generate images, which this is a PNG image, which will also translate on the web much better than Java will. So those are kind of short scope, small goals, but it's great to get them done over the weekend.
So I worked on actually looking at integrating the math description engine more with a browser-based environment, as well as taking some of the functions that were typically server-based in the math description engine and bringing those client-side so that they could be embedded automatically into an ebook, and you could actually use a lot of that technology without necessarily being connected to the web, having a live internet connection. So to do that, we ended up actually still having to use the math description engine just for the description part. So I'm going to start with a simple graph, y equals x. In this case, all right, so the sound you heard there represents this line here. It went to the math description engine, a web service, and actually retrieved the actual description. Now let's go ahead and change that formula, and let's make a steeper line. So in this case, we'll say x times 4. And so in that case, you heard a sound with a much higher pitch indicating a much steeper curve. The description's also different as well. And then we even have it working with some rudimentary JavaScript functions. So here I'm going to do a sine wave now. Actually, let me reset that. So I'm going to put in y equals sine x. So the So you heard kind of the beginnings of getting that sonification right, but essentially a frequency going up and down just like the sine curve. And once again, it got the description on a sine curve from the math description engine. And then we also did charting on the client side, all the charting, so that you don't actually have to go back to the server to retrieve the images. So we wanted to have a way to kind of be able to test things both ways. And in this case, we're using drawing on canvas using some open source libraries. But the work that Ram did around SVG is really powerful too, because that means that we can send those SVG files to an embosser, which is a type of printer that prints on raised surfaces. But what I'm really excited about is when we make that work with 3D printers, which are going to be much cheaper than traditional embossers.
So what I did this weekend was basically research and documentation. At the beginning of the weekend, we sort of laid out 3 challenges out of the many, many challenges involved with the MathTrax challenge that we wanted to approach and try to deal with. The first one was, can we take the equation and turn it into a graph using just JavaScript? So I did some research into what libraries were already available for that and passed some of that information on to the other guys. Another thing that we wanted to do was take an equation and or a graph that's already in a visual format and turn it into an audio that could be heard on any browser or device that you can have with HTML5. The problem with that, if you know about HTML5, is that the standards aren't so standard. Everybody has a different audio file format that they want to use. So we found a library called Sound Manager 2, and I documented that and put it into our Pirate Pad. And the third thing is that we want to be able to print out manipulatives so that people can feel the graph. There's an audio description engine that exists to describe what the graph looks like, but it would be so nice to be able to actually feel with your fingers what it looks like. So found out about the ways to do this cheaper. It would be so much better if we could print using the MakerBot, and the MakerBot does not print from SVG. You have to translate into STL usually. So I was investigating that and wrote some documentation on that. But then somebody pointed out, actually, the STL gets turned into G code. So found out about G code, found out about the more limited G code that's used specifically by Replicator G, which is the software that's used with the MakerBot, and got us at least theoretically closer to taking the ideas and turning them into actual technological feats. So over the next few weeks, hopefully I'll be able to take some of the information that we gathered and actually put it together into an HTML5 application. And whatever I don't do myself, all the documentation is there in the Pirate Pad, and shortly will be there on the in wiki format on the GitHub for Benetech, so other people will be able to just pick up where we left off this weekend.
Check out the Pirate Pad for our project at bit.ly/spaceapps_MathTrax. You can find the GitHub archives for the Math Description Engine project at benetech.github.com. The International Space Apps Challenge may be over, but this is an open source project, and it has potential to do a lot of good. So, if you're looking for an interesting challenge, want to learn some things about math education or HTML5 or accessibility or 3D printing, then download the code and start hacking. You can also come find us at the Freenode IRC channel, benetech-mde, or drop an email to opensource@benetech.org for more information on how you can get involved.